Welcome to Passco Africa. Here is the question. A block and system has 2 movable and 2 fixed pulleys. If the efficiency is 100%, calculate the mechanical advantage of the system. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. A car braking system works on the principle that pressure in A. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. A piece of resistance wire is 0.5 m long. If its diameter is 7.0 times 10⁻⁴ m and the resistance 1 ohm, calculate the resistivity of the material of the wire. 3.1 x 10⁻⁷. Now, try it yourself. Step 1. Understanding the formula. The resistance of a wire is given by the formula I equals ρ, where is the resistance, ρ is the resistivity of the material, L is the length of the wire, and E is the cross-sectional area of the wire. Step 2. Determining the resistivity of the material. The resistivity of a material is a measure of its ability to resist the flow of electric current. For a wire made of copper, the resistivity is approximately 1.68 multiplied by 10 to the power of -8 ohms. Step 3. Calculating the cross-sectional area. The cross-sectional area of a wire can be calculated using the formula A equals pi/2, where is the radius of the wire. Given that the diameter of the wire is 7.0 multiplied by 10 to the power of -4 m, the radius is half of that, which is 3.5 multiplied by 10 to the power of -4 m. Step 4. Calculating the cross-sectional area. Substituting the value of the radius into the formula, we get A equals pi/2 equals 3.848 multiplied by 10 to the power of -7 m squared. Step 5. Calculating the resistance. Now that we have the resistivity and the cross-sectional area, we can substitute these values into the formula for resistance, I equals ρ. Given that the length of the wire is 0.5 m, we get I equals 2.18 multiplied by 10 to the power of -2 ohms. Step 6. Rounding the answer. Rounding the answer to the correct number of significant figures, we get I equals 2.2 multiplied by 10 to the power of -2 ohms. Step 7. Verifying the answer. To verify our answer, we can use the given answer of 2.2 multiplied by 10 to the power of -2 ohms as a reference. To recap, we solved the question by 1. Understanding the formula, 2. Determining the resistivity of the material, 3. Calculating the cross-sectional area, 4. Calculating the cross-sectional area, 5. Calculating the resistance, 6. Rounding the answer, 7. Verifying the answer. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. A plastic comb used on a dry hair becomes charged and can pick up pieces of paper. Now, try it yourself. Step 1. What is charging by friction? Charging by friction, also known as triboelectric charging, occurs when two materials come into contact and one material becomes electrically charged due to the transfer of electrons. In the case of a plastic comb used on dry hair, the comb becomes positively charged, while the hair becomes negatively charged. Step 2. The role of friction. Friction plays a crucial role in charging by friction. When two materials come into contact, the electrons in the surface atoms of the materials interact and transfer electrons from one material to another. This transfer of electrons results in the creation of a net charge on the surface of the materials. Step 3. The types of charges. There are two types of charges, positive and negative. A positive charge is created when an object loses electrons, while a negative charge is created when an object gains electrons. In the case of a plastic comb used on dry hair, the comb becomes positively charged by losing electrons, while the hair becomes negatively charged by gaining electrons. Step 4. The factors affecting charging. The amount of charge transferred between two materials depends on several factors, including the type of materials, the surface area in contact, and the force of contact. The more surface area in contact and the greater the force of contact, the more electrons are transferred and the greater the charge. Step 5. The role of static electricity. Static electricity plays a crucial role in charging by friction. When two materials come into contact and one material becomes charged, static electricity is created. This static electricity can cause the charged material to attract other materials, such as paper, as we saw earlier. Step 6. The application of charging by friction. Charging by friction has several applications in everyday life, including the use of static electricity to pick up small objects, the creation of static electricity in clothing to reduce static cling, and the use of electrostatic charges to remove dust and debris from surfaces. Step 7. The importance of charging by friction in WASSCE. Charging by friction is an important concept in the WASSCE Physics syllabus. It's essential to understand the science behind charging by friction to answer questions on topics such as static electricity, electrical charges, and the behavior of electric charges. To recap, we solved the question by 1. What is charging by friction? 2. The role of friction. 3. The types of charges. 4. The factors affecting charging. 5. The role of static electricity. 6. The applications of charging by friction. 7. The importance of charging by friction in WASSCE. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome, students, to this video on physics for WASSCE. Today, we are going to explore an essential concept in physics: density, relative density, and buoyancy. These topics are crucial for your understanding of various physical phenomena, and they are a significant part of your physics syllabus. So, let's dive in and make sure you grasp these concepts like a pro. Here is the question. A solid weighs 359.0 g in air, 275.0 g in water and 250.0 g in a liquid. Calculate the relative density of the liquid. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. A stone is thrown vertically upwards with a velocity 40.0 milliseconds minus 1. Calculate the maximum height reached by the stone. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. A stone is tied to a string and whirled round. What type of motion does the system execute? Now, try it yourself. Step 1. Understanding the scenario. The stone is tied to a string and whirled round. This means the stone is moving in a circular path, and its position is changing continuously. Step 2. Identifying the type of motion. When an object moves in a circular path, it is said to exhibit circular motion. Step 3. Defining circular motion. Circular motion is a type of motion in which an object moves in a circular path around a fixed point called the center or origin. Step 4. Mathematical representation. The equation for circular motion is given by V equals omega r, where V is the velocity of the object, omega is the angular velocity, and r is the radius of the circular path. Step 5. Understanding angular velocity. Angular velocity is a measure of the rate of change of angular displacement with respect to time. It is defined as omega equals delta theta slash delta t, where delta theta is the change in angular displacement and delta t is the change in time. Step 6. Relating angular velocity to linear velocity. The linear velocity of an object moving in a circular path is related to its angular velocity by the equation V equals omega r, where r is the radius of the circular path. Step 7. Conclusion. In conclusion, the stone exhibits circular motion when tied to a string and whirled round. The linear velocity of the stone is related to its angular velocity by the equation V equals omega r. To recap, we solved the question by 1. Understanding the scenario, 2. Identifying the type of motion, 3. Defining circular motion, 4. Mathematical representation, 5. Understanding angular velocity, 6. Relating angular velocity to linear velocity, 7. Conclusion. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. A substance whose half-life is 1 year now has 1,000 atoms. This means that 1 year ago it had 2,000 atoms too. 2 years ago, it had 4,000 atoms 3. In 6 months' time it will have 500 atoms 4. In 1 time it will have 0 atoms. Which of the above are correct? Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. A tank is 1.5 m deep and is full of water. Calculate the pressure at the bottom of the. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. An object is placed at a point 18.0 cm from converging lens or focal length 15.0 cm. Calculate the magnification of the image formed. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. An object is placed in front of a plane mirror. If the mirror is rotated through an angle, theta, the image rotates. Now, try it yourself. Step 1. Understanding plane mirrors. A plane mirror is a flat, smooth surface that reflects light. When light hits a plane mirror, it bounces back, creating an image of the object in front of it. Step 2. Rotation of the mirror. Now, let's say the plane mirror is rotated through an angle theta. This rotation affects the image formed by the mirror. Step 3. Understanding the image rotation. When the mirror is rotated through an angle theta, the image rotates through an angle 2 theta. This is because the image is formed by the reflection of the light rays, and the rotation of the mirror changes the direction of these light rays. Step 4. Mathematical explanation. Mathematically, we can represent the rotation of the image using the following equations. Theta equals 2 theta. This equation shows that the angle of rotation of the image is twice the angle of rotation of the mirror. Step 5. Understanding the reason behind the formula. So, why does the image rotate twice as much as the mirror? It's because the image is formed by the reflection of light rays, and the rotation of the mirror changes the direction of these light rays. Think of it like a merry-go-round. When you rotate the merry-go-round, the people on the ride will also rotate twice as much as the merry-go-round itself. Step 6. Visualizing the rotation. Now, let's visualize the rotation of the mirror and the image. As the mirror rotates through an angle theta, the image rotates through an angle 2 theta. This is a fundamental concept in optics, and it's essential to understand it to excel in your physics exams. Step 7. Conclusion and summary. In conclusion, the rotation of images in plane mirrors is a crucial topic in physics. We've discussed the concept, the mathematical explanation, and the reason behind the formula. Remember, the angle of rotation of the image is twice the angle of rotation of the mirror. This is a fundamental concept that will help you excel in your WASSCE Physics exams. To recap, we solved the question by 1. Understanding plane mirrors, 2. Rotation of the mirror, 3. Understanding the image rotation, 4. Mathematical explanation, 5. Understanding the reason behind the formula, 6. Visualizing the rotation, 7. Conclusion and summary. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. An object of mass 0.5 kilograms is thrown vertically up with a velocity of 30.0 milliseconds. Calculate its potential energy at the maximum height. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. If v is the linear velocity of a body, omega is its angular velocity and r is the radius of the circle it describes, then the relation between v, r and omega v equals r2. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. In a pinhole camera, when the hole is large, the image formed is. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. In a system of two colliding bodies, the collision is said to be inelastic if the bodies move away in. Now, try it yourself. Step 1. Define inelastic collision. An inelastic collision is a type of collision where the total kinetic energy of the system is not conserved. This is because some of the kinetic energy is converted into other forms, such as heat, sound, or deformation of the colliding objects. Step 2. Identify the characteristics of inelastic collision. In an inelastic collision, the following characteristics are observed. The objects stick together after colliding. The total kinetic energy of the system is not conserved. The momentum of the system is conserved. Step 3. Explain the conservation of momentum in inelastic collision. The momentum of a system is the product of its mass and velocity. In an inelastic collision, the total momentum of the system is conserved, meaning that the momentum before the collision is equal to the momentum after the collision. This is given by the equation, m1u1 plus m2u2 equals m1v plus m2v, where m1 and m2 are the masses of the objects, u1 and u2 are their initial velocities, and v is their final velocity. Step 4. Derive the equation for inelastic collision. To derive the equation for inelastic collision, we start with the definition of momentum. P equals mv. The total momentum of the system before the collision is m1u1 plus m2u2, and the total momentum after the collision is v. Equating these two expressions, we get m1u1 plus m2u2 equals v. Solving for v, we get v equals /. Step 5. Explain the energy-momentum relationship in inelastic collision. In an inelastic collision, the kinetic energy of the system is not conserved. However, the energy-momentum relationship can still be used to relate the initial and final velocities of the objects. The energy-momentum relationship is given by the equation E squared equals √2 plus √2, where E is the total energy, P is the momentum, C is the speed of light, and m is the rest mass of the object. Step 6. Relate the energy-momentum relationship to inelastic collision. Using the energy-momentum relationship, we can relate the initial and final velocities of the objects. However, since the kinetic energy is not conserved in an inelastic collision, we need to use the relativistic energy-momentum equation, E squared equals √2 plus √2. Substituting the expressions for energy and momentum, we get √2 plus √2 equals √2 plus √2. Simplifying this equation, we get caret 2 plus caret 2 equals caret 2 plus caret 2. Step 7. Relate the energy-momentum relationship to the equation for inelastic collision. Using the energy-momentum relationship, we can relate the initial and final velocities of the objects. Substituting the expressions for momentum, we get caret 2 plus caret 2 equals caret 2 plus caret 2. Substituting the expression for momentum from the equation for inelastic collision, we get caret 2 plus caret 2 equals v caret 2. Simplifying this equation, we get caret 2 plus caret 2 equals caret 2 v caret 2. To recap, we solved the question by 1. Define inelastic collision. 2. Identify the characteristics of inelastic collision. 3. Explain the conservation of momentum in inelastic collision. 4. Derive the equation for inelastic collision. 5. Explain the energy-momentum relationship in inelastic collision. 6. Relate the energy-momentum relationship to inelastic collision. 7. Relate the energy-momentum relationship to the equation for inelastic collision. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. In transmitting electric power from one station to another, it is better to use a high voltage and a low current because high voltage will make. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. 1 joule of work is done when a body of mass 1 kg moves through a. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. The angle between the geographic knot and the magnetic knot is called. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. The characteristic of sound, produced by different musical instruments, which differentiates one instrument from the other is the. Now, try it yourself. Step 1. Understanding the properties of a sound wave. To begin with, let's recall the properties of a sound wave. These include frequency, the number of oscillations or cycles per second, measured in Hertz wavelength, the distance between two consecutive peaks or troughs of a sound wave speed, the rate at which a sound wave propagates through a medium amplitude, the maximum displacement of a sound wave from its equilibrium position, loudness, a subjective measure of the perceived intensity of a sound wave. Step 2. Producing different sounds with musical instruments. Musical instruments produce sound waves through various mechanisms, including vibration, friction, and resonance. For instance, string instruments like the violin and guitar produce sound when their strings vibrate. Wind instruments like the flute and trumpet produce sound when air is blown through them. Percussion instruments like the drum and cymbal produce sound when struck or hit. Step 3. Relating instrument characteristics to sound properties. Now, let's explore how the characteristics of different musical instruments relate to the properties of sound waves. Frequency. Different instruments produce sound waves with distinct frequencies, ranging from low notes to high notes. Wavelength. The wavelength of a sound wave is inversely proportional to its frequency. For example, a low-frequency sound wave has a longer wavelength than a high-frequency sound wave. Speed. The speed of a sound wave is dependent on the medium it propagates through. In air, the speed of sound is approximately 343 meters per second. Amplitude. The amplitude of a sound wave determines its loudness. A larger amplitude corresponds to a louder sound. Loudness. Our perception of loudness is influenced by the amplitude and frequency of a sound wave. Step 4. Exploring instrument-specific characteristics. Let's examine the characteristics of specific instruments and how they relate to sound properties. Violin. The violin produces sound waves with a high frequency and a moderate amplitude. Its strings vibrate to produce sound. Drum. The drum produces sound waves with a low frequency and a high amplitude. Its head vibrates to produce sound. Flute. The flute produces sound waves with a high frequency and a moderate amplitude. Air is blown through its embouchure hole to produce sound. Step 5. Analyzing the relationship between instrument characteristics and sound properties. By analyzing the characteristics of different instruments, we can infer the properties of the sound waves they produce. For example, an instrument with a large amplitude will produce a louder sound. An instrument with a high frequency will produce a higher pitch sound. An instrument with a low frequency will produce a lower pitch sound. Step 6. Applying knowledge to real-world scenarios. Understanding the characteristics of sound produced by different musical instruments has practical applications in various fields, including music production. Knowing how to manipulate sound wave properties can aid in creating unique sound effects and instrument timbres. Acoustics. Understanding how sound waves propagate through different mediums can inform the design of concert halls, auditoriums, and other acoustic spaces. Hearing aid technology. Knowledge of sound wave properties can aid in developing more effective hearing aids and sound amplification devices. Step 7. Conclusion and key takeaways. In conclusion, the characteristics of sound produced by different musical instruments are influenced by their unique properties, including frequency, wavelength, speed, amplitude, and loudness. By understanding these relationships, we can appreciate the diversity of sound waves and their applications in various fields. Key takeaways from this video include: different instruments produce sound waves with distinct frequencies, wavelengths, speeds, amplitudes, and loudness. Instrument characteristics can be inferred from the properties of the sound waves they produce. Understanding sound wave properties has practical applications in music production, acoustics, and hearing aid technology. To recap, we solved the question by 1. Understanding the properties of a sound wave, 2. Producing different sounds with musical instruments, 3. Relating instrument characteristics to sound properties, 4. Exploring instrument-specific characteristics, 5. Analyzing the relationship between instrument characteristics and sound properties, 6. Applying knowledge to real-world scenarios, 7. Conclusion and key takeaways. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. The following are all luminous bodies except the Sun. Now, try it yourself. Step 1. Understanding luminous bodies. Luminous bodies are objects that emit light due to an increase in temperature or an electrical discharge. This emission of light can be seen through a process called incandescence, where the atoms or molecules of the object vibrate rapidly, releasing excess energy as light. Step 2. Examples of luminous bodies. Examples of luminous bodies include the Sun, stars, light bulbs, and even electrical appliances such as toasters and heaters. These objects emit light due to an increase in temperature or an electrical discharge. Step 3. The Sun as a luminous body. The Sun is a luminous body that emits light due to nuclear reactions occurring within its core. These reactions involve the fusion of hydrogen atoms into helium, releasing a vast amount of energy in the form of light and heat. Step 4. Identifying non-luminous bodies. A non-luminous body is an object that does not emit light due to an increase in temperature or an electrical discharge. In the given options, the Sun is a luminous body, but the other objects listed may or may not be luminous bodies. Step 5. Analyzing the options. Let's analyze the options provided: the Sun, light bulbs, electrical appliances, and stars. Based on the definition of luminous bodies, the Sun, light bulbs, and stars are all luminous bodies. However, electrical appliances such as toasters and heaters may not necessarily be luminous bodies, as they may not emit light. Step 6. Conclusion. After analyzing the options, we can conclude that electrical appliances are not necessarily luminous bodies, whereas the Sun, light bulbs, and stars are all luminous bodies. Step 7. Understanding non-luminous bodies. Non-luminous bodies can be objects that absorb light, reflect light, or emit light due to chemical reactions. Examples of non-luminous bodies include objects that absorb light, such as black paint, or objects that emit light due to chemical reactions, such as fireflies. To recap, we solved the question by 1. Understanding luminous bodies, 2. Examples of luminous bodies, 3. The Sun as a luminous body, 4. Identifying non-luminous bodies, 5. Analyzing the options, 6. Conclusion, 7. Understanding non-luminous bodies. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. The length of wire at 30.0 Omicron C is 1.002 m. If the temperature of the wire is raised to 105.0 degrees Celsius and the linear expansivity of the metal is 1.89 multiplied by 10⁻⁵ calculate the increase in length of the wire. 1.04 multiplied by 10. Now, try it yourself. Step 1. Understanding resonance. To understand resonance, imagine a pendulum swinging back and forth. If we apply a force to the pendulum at the right frequency, it will start vibrating with maximum amplitude. This is resonance. Step 2. Formula derivation. The formula for resonance in SHM is given by omega equals square root, where omega is the angular frequency, K is the spring constant, and m is the mass attached to the spring. Step 3. Explanation of the formula. The formula omega equals square root shows that the angular frequency of the oscillating system is directly proportional to the square root of the spring constant and inversely proportional to the square root of the mass. This means that as the spring constant increases, the angular frequency also increases, and as the mass increases, the angular frequency decreases. Step 4. Resonance condition. For resonance to occur, the frequency of the external force must be equal to the natural frequency of the oscillating system. This is given by the equation F equals omega/2 pi. Step 5. Critical damping. In a damped oscillator, the amplitude of the oscillations decreases over time due to energy loss. However, if the damping coefficient is critical, the amplitude will remain constant, and the oscillations will become periodic. Step 6. Energy transfer. When an external force causes an oscillating system to vibrate at its natural frequency, energy is transferred from the external force to the oscillating system. This energy transfer is maximum at resonance. Step 7. Conclusion. In conclusion, resonance is a fundamental concept in simple harmonic motion. Understanding the formula for resonance, the resonance condition, critical damping, and energy transfer will help you excel in your WASSCE Physics exams. To recap, we solved the question by 1. Understanding resonance, 2. Formula derivation, 3. Explanation of the formula, 4. Resonance condition, 5. Critical damping, 6. Energy transfer, 7. Conclusion. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. The moving coil galvanometer works on the principle that a current carrying coil in a. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. When a hydrometer floats in a liquid, it means that acceleration due to gravity is. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. When a shunt is connected across a galvanometer, its purpose is to increase the net. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following are emitted from a radioactive substance without altering the mass number or atomic number of the substance? Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following can reduce the sensitivity of a liquid in glass thermometer? I. Increasing the size of the bulb. 2. Increasing the length of the stem. 3. Using a liquid of high specific heat capacity. 4. Increasing the bore of the tube. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following factors is common to both fission and fusion reactions? Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following is not a derived unit? Now, Try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following material is non-magnetic? Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following material is not a component of a Daniell cell? Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following parts of the human eye corresponds to the shutter of the camera? Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following sources of energy is renewable? Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following statements does not apply to an ideal gas? Now, try it yourself. Step 1. Understanding the ideal gas law. The ideal gas law is a fundamental concept in physics that describes the behavior of gases. It is a mathematical equation that relates the pressure, volume, and temperature of a gas. Step 2. Defining perfect elasticity. Perfect elasticity is a property of collisions where the molecules retain their kinetic energy after a collision. This means that the molecules do not lose any energy during the collision. Step 3. Understanding perfect inelasticity. Perfect inelasticity is the opposite of perfect elasticity. In a perfectly inelastic collision, the molecules stick together and lose their kinetic energy. This means that the molecules do not retain their kinetic energy after the collision. Step 4. Examining the properties of ideal gases. Ideal gases are hypothetical gases that obey the ideal gas law. They are assumed to have the following properties. The molecules are point particles. The molecules do not interact with each other. The molecules have no intermolecular forces. The molecules are perfectly elastic. Step 5. Analyzing the statement. The statement, "the molecules are perfectly inelastic," contradicts the properties of an ideal gas. As we discussed earlier, ideal gases are assumed to be perfectly elastic, not inelastic. Step 6. Conclusion. Based on our analysis, we can conclude that the statement, "the molecules are perfectly inelastic," does not apply to an ideal gas. Step 7. Memorization approach. To help you remember this concept, let's create a memory palace. Imagine a palace with 7 rooms. Each room represents a property of an ideal gas. Room 1, point particles. Room 2, no intermolecular forces. Room 3, no interaction between molecules. Room 4, perfect elasticity. Room 5, ideal gas law. Room 6, temperature in Kelvin. Room 7, pressure. Now, imagine walking through the palace and visualizing each room. This will help you associate the properties of an ideal gas with the correct concept. To recap, we solved the question by 1. Understanding the ideal gas law. 2. Defining perfect elasticity. 3. Understanding perfect inelasticity. 4. Examining the properties of ideal gases. 5. Analyzing the statement. 6. Conclusion. 7. Memorization approach. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following statements is not correct about the astronomical telescope in normal use? Now, try it yourself. Step 1. Understanding the basic components of an astronomical telescope. An astronomical telescope consists of two main components, the objective lens or mirror, and the eyepiece. The objective lens or mirror collects light from a distant object, while the eyepiece magnifies the image formed by the objective lens or mirror. Step 2. Explaining the concept of magnification. Magnification is the process of increasing the apparent size of an object. In an astronomical telescope, magnification occurs when light from the objective lens or mirror is redirected through the eyepiece. The eyepiece increases the image size, allowing us to observe distant objects more clearly. Step 3. Understanding the concept of angular magnification. Angular magnification is the ratio of the angle subtended by the image at the eye to the angle subtended by the object at the eye. It is calculated using the formula, angular magnification equals focal length of eyepiece / focal length of objective lens or mirror. Step 4. Understanding the concept of linear magnification. Linear magnification is the ratio of the size of the image to the size of the object. It is calculated using the formula, linear magnification equals angular magnification multiplied by distance from eyepiece to object. Step 5. Explaining the concept of the telescope's normal use. In normal use, an astronomical telescope is used to study distant objects in the sky. The objective lens or mirror collects light from the object, and the eyepiece magnifies the image formed by the objective lens or mirror. Step 6. Understanding the concept of resolving power. Resolving power is the ability of a telescope to distinguish between two closely spaced objects. It is calculated using the formula, resolving power equals 1.22 multiplied by wavelength of light / diameter of objective lens or mirror. Step 7. Understanding the concept of limiting factor of an astronomical telescope. The limiting factor of an astronomical telescope is the factor that determines the maximum distance at which an object can be observed clearly. In normal use, the limiting factor is usually the diameter of the objective lens or mirror. To recap, we solved the question by 1. Understanding the basic components of an astronomical telescope, 2. Explaining the concept of magnification. 3. Understanding the concept of angular magnification. 4. Understanding the concept of linear magnification. 5. Explaining the concept of the telescope's normal use. 6. Understanding the concept of resolving power. 7. Understanding the concept of limiting factor of an astronomical telescope. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following statements is correct about a progressive wave? Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following systems cannot be used to demonstrate simple harmonic motion? Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following takes place when waves from two close vibrating sources combine in such a way that the crest of the waves from one source always arrive at the same time as the crest of the waves from the other source? Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep.